Hi everyone, in this video we are going to try to learn about outliers and influential points. So what we are going to do here is that I'm going to create some random data. Like I'm going to let my x to be a number, a numerical variable from 1 to 9. So that means if I define x to be 1 colon 9, that means x will take the values from 1 to 9. And then I define my y, which is 2 times x plus 1. So if I run that line and I run y, you can see I have a x variable and a y variable now. As you may know, you can definitely draw a plot for x and y, and it will be like this. A perfect linear trend between x and y. Then I want to try to build a model using LM function, so it will be y tilde x. And then I can name it my model 1. So if I run that, that means I have tried to build a linear regression model with slope being 2 and intercept being 1. I can definitely add that model line into my scatter plot. So you can see it's a perfect linear model because that is how we created the data, how we created our y based on x. So now I'm going to do something to the data. I'm trying to add one observation for x and y. So you can see I'm going to define my x new to be my original x, but I'll give it a 10th value. So you can see my x has only 9 values, but I'm going to give it a 10th value, and I'm going to name it as 6. And then I create a new y. It is the same as my original y, but I also add a 10th value for it. So it's 20. So now I can run all these 4 lines. That means I actually just created a new x variable, which is x new, with 10 values, and y new with 10 values again. So I can do the same thing, x new, y new. So I have the scatter plot. As you can see, there is a point over there is a little skeptical. So I'm not sure if that's an outlier or if that's an influential points, right? So I can also define my model 2 as the y new tilde x new. So this is another model, and we can add that model to the scatter plot like this. So as you can see, that dot is kind of far away from the major line. One thing we can do is to try to add the original model line to the scatter plot, which would mean like we are taking that dot away. We are taking one observation away, and we are trying to see what that line, what that new model look like. So we can do apply M1, and then we can also change the color of that line so that it's not the same as the original model line. So let's run that. And you can see the red line is actually like the perfect model when we have our x and y with 9 observations, which is also the model line without that skeptical point. So you can see that dot, that added observation, actually dragged our model line from the red one to the black one, which is a little bit drag. It's not that influential, like totally changed the direction of the model line, but it changes a little. we can now check the residuals of this model 2 and see if that dot is really an outlier. So we can run the residuals function on model 2, and we can draw a box plot of the residuals so that you can see if in your box plot you are having a very obvious outlier. So if you zoom that picture, you can see the box plot is like a squeezed box to the bottom, and there is one dot on the very top. So this dot is actually the value that we added, which is the pair of 6 and 20. So that you know, for this added value, it seems like it is a big outlier, but as you can see from the model line, it's kind of a small drag in terms of the slope of the model. You can also run M1 and see the slope is 2, and the slope for M2 is kind of 2.1. So there is a small change. So now I want to take a pause to add the note for my R code. So this is my define my X variable, define my Y, and then I draw a scatter plot of X and Y. And then I build the linear regression model for X, Y versus X. And this is like add the model line to the scatter plot. So these are the typical steps when you build a linear regression model. So you want to have your data, you want to look at the plot, and then you want to build the model and see how the model fits your data. Create a new X new, and this one is for create Y new. And this one again is a scatter plot, and this one is the model. And the 2 steps here, so add the model with 10 pairs of X and Y, but the next one is add the model line without the outlier, so that you can see if that added dot, that outlier is influential to the direction of the model, or it is like a little change. So this is getting the residuals, and the box plot on the residuals is to check outliers. So okay, so the next thing I want to talk about is the influential points. I want to give you an example by defining my XX and YY. So define my predictor and response variable. So I'm going to define my X with 10 values from a uniform distribution from 0.5 to 0.6. So this means I'm creating a list of values with 10 values in total. They are all between 0.5 and 0.6. But my 11th value is 20. And the same thing, I'm going to define my Y. I let it to be 1 from 10, and my 11th value is 30. So by now, I have created my predictor and response variable with 11 observations. So now, let's look at the scatter plot. See, that is the scatter plot. And you can see we have a lot of dots in the corner, and we have one dot like on the top right. So without looking into detail of it, I want to draw the model line. I want to fit a simple linear regression. So I define it as M3, and then I run LM function of M3, and then I add that model line. Let me change the color to make it more interesting. So like this. So that is the model line. You can see with that dot, the model line is like tilted towards that dot. But you can imagine, what if without that dot? What if without that outlier? So I'm going to let my x just the 10 values that we created, like without this combination 20 and 30. I just take the first 10 values. Same thing for y, I just take the first 10 values. And then I build my model 3 with these 10 values. And then I add that model 4. Did I say model 3? So I actually meant model 4 because I'm trying to create a regular model without considering that outlier. So you can see I do outline and I use that color orange. So I'm going to run this. So you can see what's the dramatic change here. With that outlier, my blue model line is like upward trend dramatically. But without that outlier, my orange model line is a little towards the middle, right? So you can see this outlier is actually very influential to the model. So this dot, you can call it an outlier and an influential point. So let me go back to the previous one. With that dot is the black line. Without that dot, it is the red line. So you can see that's a small change. And that's a dramatic change. Okay, that's about it. I hope you enjoy this material. Thank you.